Hey all, how you doing? This is just a video to show you how to use a really cool tool for bioinformatics multiple sequence alignment. This is called Clustal Omega, and I have it full screen so that you can see the URL, but you can also just Google it as well. I'm going to use it for a protein alignment and a way that we can use it not only for the alignment similarities, but also to create a phylogenetic tree, which is definitely the theme of this module. So the first thing you have to do is get a bunch of sequences, and I have some here. This is just using Notepad with a whole bunch of sequences for the P53 tumor suppressor protein in different organisms. Now, I shortened the names of these. Obviously, there's different kinds of shrimp and different kinds of hamsters, but just so the alignment's easier to read, and you'll see why. So these are protein sequences. You'll notice that they all start with M for methionine. And we're going to go ahead and just take this and we're going to copy all of it. And basically from here, we're choosing protein, and I just, oops, let me see. And I just do paste. And so I pasted in all of the sequences there. I'm going to do a simplistic version of this. There's all kinds of different outputs, but I do Clustal W with character counts, and you'll see what those mean in a second. I can give it a title. I don't need to do that. And I hit submit. Now I'm going to pause the video because sometimes this takes, anywhere from 30 seconds to 2 or 3 minutes. That wasn't too bad. That only took about 30 seconds or so. And so we can see here that what we have, again, you can see how everything in this course builds off of what you learned before. So now we have a multiple alignment with different amino acids, and this is the chart indicator of what they are. And I can take this little bar here and just kind of scroll along the whole thing. And we can already see that there's areas of similarity that a lot of these have, and there's definitely areas of distance. I mean, if you take a look at shrimp, I mean, that is definitely a bit different than all the rest. And you can see it still starts with methionine. So with this area, I have areas of difference, but I also have some conservation as well. Some areas of absolute similarity, especially right here. Between almost all of these. Obviously, the shrimp is a bit different in some of these. And so, this is just, and again, what we talked about in the last video, you can see here that the isoleucine and valine are the same color because of their relative characteristics of similarity as amino acids. So what else can we do from that? So we can look at a couple different things. Let's just go first of all, if you want, to the tool output. And so this is like what I like to call the old school way, and you can download this. But this also has here indicators of kind of where there's some differences and similarities. Again, the asterisk being completely similar, and the dot being some area of difference. And so because of that, that's one way to look at it. It's the older way that I used to look at it. But let's go to phylogenetic tree. So here is basically the output data of the relative scores, and then this is the actual tree itself. And let me make this a little bigger. And so using this information, this should make a lot of sense, kind of given what types of organisms these are. And it's clearly showing that the human and the chimpanzee. Now let me go ahead and zoom in a little bit more so I can talk about this. Control plus. Let me go here. There we go. That's a pretty good view. So if we look about it like this, we really can see that this makes sense with what you would expect here, that we have the human and the chimpanzee very, very, very closely related. And then, of course, we have a node here adding on the monkey, which also makes sense as far as its relatedness to us. And then the wolf, and as we can see here, the shrimp is kind of way by itself, being an aquatic organism. And then, of course, we have an amphibian, which also makes sense, being closest to the frog. And, of course, we have mouse, and hamsters. So we can see that this makes sense with kind of what we would expect. And in this case, we're just using the similarities of scoring between them to create this tree. So I just wanted to kind of show you how you can use Clustal Omega for sequence alignment.